Now that we've talked about the new properties of parallel lines with the weak parallel line postulate, as well as the properties of parallelograms, we can now look at another special type of segment that interacts with triangles called a midsegment. And a midsegment, by definition, is a segment connecting the midpoints of two sides of a triangle. So go ahead, pause the video, copy down this definition as well as the diagram, come back when you're ready to move on and see two important properties of midsegments. So you might notice in this diagram that the setup is very similar to the weak 3 parallel line postulate that says if 3 parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. And looking at this diagram again, we can see that we have some lines that cut congruent segments, even though it's not exactly in the same setup. And that's what we're going to use to prove one of the properties or one of the theorems related to midsegments, and that's a line that passes through the midpoint of one side of a triangle and is parallel to its third side must pass through the midpoint of the side that it intersects. So go ahead, pause the video, copy down this statement related to midsegments, and while you're at it, see if you can find out how we're going to prove that AN is congruent to NC. It is a very short proof. Gave a little bit of a hint to it earlier in the video when I referred to another postulate that we know. But pause the video, copy this down, see if you can come up with a proof on your own. Come back when you're ready to see the proof as a part of the video. So, like I said, this is a very straightforward and very simple proof. Statements and reasons. What are we given? Well, we're given that ABC is a triangle. We don't actually need to state that because it's in the diagram. The important given information here is that MN is parallel to BC, and that AM is congruent to BM. That's our given. So what does that mean? Well, in the diagram right now, there's not a whole lot we can do with it. But if we go back to another postulate that we saw with parallel lines, thinking about the fact that if we could prove that BM and AM were cut by 3 parallel lines using the weak 3 parallel line postulate, then we could say that every transversal has to also be cut into congruent segments. We don't have a third line that goes through A, but we can construct one. We can say that this line L that goes through A is parallel to MN. Why? In this case, it's because of the Euclidean postulate that tells us that that line exists. So L is parallel to MN, and A is on L. Why? Because of that Euclidean postulate, which I'm just going to abbreviate that way. Great. Now we have AB being a transversal for line L, line MN, and line BC. AM and MB are congruent. Therefore, by the weak 3 parallel line postulate, every transversal of L, MN, and BC must be cut into congruent segments. And AN is congruent to NC by the weak 3 parallel line postulate. So there we go. We know that if a line passes through the midpoint of one side of a triangle and is parallel to the side that it doesn't intersect, it must also pass through the midpoint of a third side. Therefore, this line MN must be a midsegment. And this is going to lead us to something called the Midsegment Theorem. And the Midsegment Theorem says that the midsegment of a triangle is parallel to the side it does not intersect and is half of that side's length. So we are not going to prove this as a part of this video. You're actually going to go through the proof as a part of your practice. But before this video ends, go ahead, pause the video, copy down the Midsegment Theorem as well as the diagram below. Do a little bit of strategizing for what you think might be helpful for doing these proofs. The proofs in the practice are going to give you some hints as we go. But pause the video because the video is about to end and copy this down.